Um, so my name is Marzieh, and I'm a postdoc at Yale. And so this work is a joint work between Clarkson University and Yale University. And the project is interpretable and high performance hate and offensive speech detection. It's an ongoing work. And so I would like to first introduce the problem statement. So we know that social media platforms are being used widely throughout the world because of their easy use, because in a couple of seconds you can share your opinions and ideas. And also it's free of charge. So there's a lot of posts like going around spreading. The good thing is that there's this platform that can advocate freedom of speech and people can share their opinions, but it could also be a double-edged sword in the case that it can contain hateful and offensive speech. A lot of researchers have been working on that basically. And there's a lot of discussion, especially in recent years in Congress, about how social media is like trying to control that. It could create a hostile environment in terms of political situations, elections, and stuff like that. And also, I think it could silence a certain group. It could be based on religious, it could be based on disability, it could be based on people of color and stuff like that. So that's another important discussion that is being discussed basically. So in this research, we think that detecting hate speech is important, and not only detecting it, but separating it from offensive speech, because basically the potential of social media platforms is to give people the ability to share their ideas. And we want to try to eliminate or not eliminate people from sharing their ideas. So we're separating offensive from hate speech, because sometimes you can get offended by a post, but that doesn't mean necessarily that you can ban that person, because it could not exactly be hate speech. So for that, we found two definitions from the Davidson et al. Paper. And one of them is language used to express hatred towards a targeted individual group. So that's the definition of hate speech, referred to from another paper. And the definition of offensive speech is impolite, rude, or vulgar language expressed towards an individual or group. So based on that, we try to go forward and separate hate and offensive speech. So the question is why it's important to separate them, because social media platforms can have different types of restrictions based on those types of speeches, as I explained. And there's a lot of challenges in detecting hate speech. There's context-based challenges. Facebook tried that, for example, and they flagged Declaration of Independence surprisingly as hate speech. It could be reasonable because like if you look at something like a constitution or Declaration of Independence that's like written decades ago, centuries ago, and I mean the language used at that time is different. So that's an important thing to even consider when you're creating a model. Okay, aside from how important it is to detect hate speech, it is the other important thing is the ethical part of like banning someone and providing justification for banning somebody. So the lack of interpretability can also make people move to an alternative platform such as Parler, for example. So that's an important thing to think about. So that can also produce a lot of other problems as it has. So our goal is, based on what I just explained, is to create a high performance model that can detect hate speech separated from offensive speech. And the next thing is try to make the model more explainable. So that's the ideal model that we're looking for. So the data set that we've used is the data set from Johnson et al. It includes 80,000 annotated tweets. Labeled ideally as hate, offensive, neither, like that was what we wanted. And why we use this data set, because it was reliable enough, it was tested enough, and the size is medium. I do think that in the future, because it's been ongoing work, we could use more like bigger data sets, which is closer to the real world type of data sets in social media. And we picked this data set also the other reason was that it was imbalanced and it's based on real users. And when you're talking about real users, mostly everybody's like neutral, or they're not really talking about hate speech or even offensive. But there is like 5,000 hate speech here and 27,000 like gray area offensive speech, and 52,000 like neither. So that all totals to 80,000. And so the first thing we did was to visualize it based on a very simple technique, word cloud. And you can see in class hate, you can see the words, the F words and the N words more than anything else. And in the offensive speech, you can see F words more than anything else. And in the class neither, you can see neutral words such as like and get more than others. And also to be more sure about what's going on between hate and offensive speech, we performed T-BERT, a lightweight version of BERT that extracts keywords. And we saw that in the class hate, there's more the N word, and the class offensive, there is more like douchebag and the B word. So after looking at the data set, why did we pick this model? XGBoost is the goal of this slide that I just brought. The first thing is that it converts weak learners to strong learners. It goes in a boosting way, and the model gets better by correcting the errors. And it's an extreme gradient boosting, has everyone's visualization. These are the good things about XGBoost model. I think also you might ask why not neural networks, because in casual competitions, there were the competitions that in medium size data sets, XGBoost was winning over neural networks, which made it a good fit. And we didn't have a large data set for this paper. But in the future, I think it's a good thing to consider. It performed very well on imbalanced data sets, and it gave us really good insights of when we add a feature, how it goes and how the score goes, basically. And it has inbuilt cross-validation. So this part is about feature that I included in the XGBoost model. So step by step, I added these features. And in the next slide, I will talk about how the score changed based on these features. The first thing that I added was, the whole problem statement is about detecting hate and offenses. So the first thing that came to my mind was sentiment. So I used the Vader sentiment analyzer, but I know that there's more sophisticated way of measuring sentiment, like even BERT has that. And I think that's another future work that I'm also working on that on other papers. And the other thing that I added was part of speech tagging and named entity recognition. And that one is like looking at which part of which part of the grammar it is, and also if the narrative, like if it's this organization talking or the person. So it would just tag it as like organization or a person. Let's say if it's the president talking, it would tag it as a president or a person. And then and we use the spatial library for that, and I added hashtag dimensions. As you can see, a lot of them in the tweets as the next feature. I used the Python preprocessor library for it, and emojis and other symbols, because those I thought that would add a lot of sentiment. The libraries used were emojis and regex. And at the end, based on literature review, I had some other papers. TF-IDF was a good fit for the feature, and we used the scikit-learn package for it. So it's the term frequency mixed by the inverse document frequency. As you can see here, we have the scores when we added these features. I used F1 score instead of accuracy because we have imbalanced data set. It's a harmonic mean between recall and precision. It makes it a better fit here. So when I first added the sentiment in the table, as you can see, it detected two classes, neither and hate. So nothing happened with offensive. But then when I added the POS NER, it got a little bit higher. and hashtag and mention, it's not noticeable. When you add hashtag and mention and then text symbols, the offensive class, as you can see, goes a little bit higher. But at the end, when we added TF-IDF, you can see that the offensive language goes to 75% and it's detected. And for hate, detected from the start, but with all of these features, they got higher and higher until 87%. And the neither class was kind of high and until 97%. So that made our model better and better with the inclusion of each of these features. So after this F1 score that we got with including all of these features, we thought that we need to compare our model to other models. One of them that I thought that would be good was LSTM, long short-term memory. It's a type of RNN, as you know, and it's capable of learning long-term memory. It's good for long sequences like text. And the other one was Autoglon. It's introduced by Amazon, automatically cleans it, and it's less developer level involvement. It's easy to use. It has good performance on supervised ML models. The other one is a state-of-the-art NLP technique, basically before BERT. It's implemented in the FastAI, basically deep learning library, and good performance on various NLP tasks. I do think that, again, another future work here is to add BERT and even more models to compare. And so this is the result of our comparison, as you can see. The first table shows it when we have the imbalanced data set, and the second one shows the scores when we've downsampled the neither and offensive to 5,000, which basically tries to equalize all the classes together. As you can see, hate is higher in all of them in the first table and also in the second table, but it's closer. And the offensive in the second class, second table is higher than all of them. And neither is also either equal or higher. But neither was never a problem, basically. It was always high. So this is the result of our model, the scores. So at the end, after getting this high performance model, or high enough model, we thought about adding another method, which is basically the second goal of our research work, and it's explainability. And what we came up with, or what we found, was the SHAP method. And it's a unified framework for interpreting predictions. And the values or the importance values are based on the game theory. And if you want to know deeper about that, I will refer to the SHAP paper. I brought it into the references in the slides. And this is one of the examples of the tweaks that when we apply this method, how it shows or how it explains. So for example, the tweet, if you still hate this N-word, this has been classified as class hate. And this tree explainer from SHAP shows how much, first of all, the base value is here, and it's higher means like it's basically hate speech. And why, and the red part shows like why it's been included as hate speech or categorized as hate speech. And the word hate plays a significant role here. And the blue parts are that they don't really play that much role here. So that's what it's basically saying. So that's one of the methods that we used. I also think that for our ongoing work, we could include other explainability models, and even we could come up with our own explainable model. So the conclusion of our work, or the takeaways, first of all, I think what our work is trying to say, that it's important for lowering the chance of minority groups to get attacked for countries such as the United States. It's important to detect hate speech and even separate them from offensive speech and for the purpose of freedom of speech, trying to limit the number of people being banned, it's important to do that and come up with these types of models. And what we do is we assist in the social media platforms in coming up with this model, high performance model to detect hate and offensive speech. And we show that our model outperforms other state of, or I mean, it's like either very close or outperforms other state of the art models. And at the end, we apply an interpretability model or explainability model in justifying how the results get predicted. And that's SHAP that we've added. And I would like to talk about some of the limitations. I think when I was going through the slides, I did talk about it in the future work. I think one of the important things about Twitter is demographic characteristics. I do think that that matters a lot. If you have that type of information, the context of the language and everything can change based on the demographic of, the demographic information. Also, the context can be a feature itself, meaning that, for example, when a community such as people of color are talking about themselves, they use the N-word. That doesn't necessarily mean it's hate speech. So that's another feature. It's more complicated, but that's another feature to take into account. Another thing is that we didn't actually use adversarial testing. I think that's another thing to consider. And as I said, I think the data set should be bigger in the future and to meet the real world social media platforms. And also the models that we're comparing should go forward, and maybe Dart, Elmo, and others that are really good with text. So those are like some of the limitations and future work that we thought about. And at last, I also talked about we can come up with other explainable models or even apply other models such as line and then compare how this justifies and compared to the other ones. So these are the references that I thought that were important. There's more of the references in the paper itself, but these are like where we got the data set from, the SHAP paper and things like that, basically, and the autoglan and the models papers. Thank you for your attention. If there's any questions, I would be happy to answer.
Thank you, Marzieh, for this very good presentation. Very interesting. I'm just going to check whether there's any raised hands. If anyone wants to ask a question straight away here in the audience. In the meantime, while we're waiting for a question, yeah, I was quite interested. In particular, you said that you're using SHAP, and from the visualization that you showed, it looked like quite a good explanation in a sense, like this red-blue line. In the end, it showed like it should have explained nicely why this thing is actually gets this quote. But clearly, as you said in your limitations, it somehow also depends on the context. So is this like what you said? It also depends who you explain it to. It's like somehow it depends on the audience you're talking to, on the context and stuff like this. I don't know, like I'm just very curious about this. So what are your thoughts on that? Do you think you would just want to use a different explanation model or explanation method, or would you said you want to develop your own based on your experience?
Yeah, but what I was thinking was that if I apply a couple of them, or at least the most important ones like line, SHAP, and others, and there were some interesting ones I got introduced today. Maybe by that time I will know like the different ones, and then I could come up with my own. I think the first step is to apply different ones and compare them first of all and see the limitations of each one. And yeah, I do think that text especially is very very, very hard to detect. Like the context itself, it's always like that. It's not just for explainable models. But any other types of models, like it's always hard to get the context out of it. I mean, it's an ongoing thing. So I'm not sure if I come up with my own, it would be perfect even, but something that could get the text, yes, of course. Get the
Would you,
context.
yeah, sorry. Would you say it also depends on, I mean, like you're looking at this specific thing, looking at texts, which are, you want to distinguish between hate and offense. So do you think this kind of explanation model or the context model, would that depend, do you reckon this would be different from your application than to other application, which seems quite specific? Like you have quite a cultural background, or is that more general? What do you think? I
Um,
mean, general across different applications.
I do think it depends very much on the culture. Like there's also even some hateful jokes that you can't even like tell the model like in different like contexts. There's jokes about another community that it's really hard to detect those types of things. So yes, it very much depends on even the culture itself, and that's another thing. Like I think even I mean, I had an interview with LinkedIn. I mean, that was one of the things that they asked, like, how would you consider like uh, some of those types of things, to like if there's like those type of cultural or hidden jokes inside, how would you consider it in the ranking system or for explainability? And yeah, for now I just see that you have to have a database of those, but I think it's more complicated than that, and yeah, it's an ongoing discussion. Yeah. Yeah.
Thank you very much, Marzi. I don't want to ask questions all my own, but I can see there are no more questions. And also, well, I still have to give my talk. So thank you, Marzi.
Thank you.
Excuse